Now there are 3 cells. A battery that has 3 cells. 2 volts, 2 volt, 2 volt with 0.5 ohms resistance. So each of the cells in the battery has 2 volts with 0.5 ohm resistance. Then it is connected to an external resistor of 2 ohms, which is in turn connected to 2 resistors that are in parallel, 3 ohms resistors. The first question, very interesting, says, calculate the effective external resistance. So let's tackle that one first. Solution. So how do we get the effective external resistance? So for us to get the effective external resistance, what we need to do is we'll first of all calculate this resistance in parallel. That is 1 over RT is equal to 1 over R1 plus 1 over R2, which is equal to 1 over 3 plus 1 over 3. This is 3, this is 3. So if this is my R1, this is my R2. Then 1 over RT is equals to LCM of this is 3, 1 plus 1, which is 2 over 3. If you do your cross multiplication, you are going to see that 2RT is equals to 3. Therefore, RT is equals to 3 divided by 2, which is 1.5. Wow! See how simple it is. So, that is the step towards getting the final answer. This is not the final answer yet. The question says you find the effective external resistance. So, you have succeeded in getting the effective resistance of the resistors in series, in parallel. So, we now connect it to this other one that is here. It is now in series. So I'm now going to say that the effective external resistance will be RT down, R capital T must be equals to R1 plus R small t. Because it is now in series connection. Series connection of resistors. You add the values of the resistance of the resistors. So RT is equals to R1 now is 2 ohms plus RT is 1.5 ohms, which is 3.5 ohms. That is the final answer to the question A. Question number 1A. We have the final answer to be 3.5 ohms. You can see it's not difficult, it's not hard. It's just for you to go through the puzzle of the thinking, So let's go to B part of it. This says, calculate the current in the circuit. So remember, for you to deal with this, current in the circuit is equal to E over R plus small r. What is this R? This R represents the RT that I have calculated. And this is small r. This small r here represents the internal resistance of the cells. And each cell has 0.5. So that's to say that our small r is equals to 0.5 plus 0.5 plus 0.5. So small r will give you 1.5 ohms. So our small r for the cell, because the cells are in series, give you 1.5. So I'm going to add that the current in the circuit is going to be equal to E. E is the PD. That is the potential difference, the E.m.f, the E.m.f of the cells. And interestingly, the cells are connected in series. So therefore, the E is equals to, let me put it this way. ET is equals to 2 volts plus 2 volts plus 2 volts, which is equals to 6 volts. So we now have, because the cells are in series, when cells are connected in series, the total E.m.f of the cells will be addition of their values. And that's how we're having 6 volts now. So current is equals to 6 volts divided by this R here, we've got calculated it to be 3.5 ohm plus 1.5 ohms. So this is 6 divided by 5. So current then is equals to 1.2. It is 1.2 ampere. Then the third question is asked to calculate the lost volts in the battery. The lost volt in the battery is equals to V is equals to I, the current in the circuit multiplied by R, which is the resistance of the cells. The resistance found in the cells. And we have calculated the resistance in the cells to be 1.5. So this is going to be 1.2 multiplied by 1.5. Or the lost volts in the battery is equals to 1.8 volts. You can see that the question is not really difficult. It is not. So this is the question. I want you to make attempt on this question number 2. I've just changed the values of the cells and the resistance of the resistors. So the question remains the same. You calculate the effective external resistance, you calculate the current in the circuit, and the lost volts in the battery. Remember, if you are among the first 5 persons to get the question correct, and you share the video and followed our page, you will receive an airtime giveaway. Thank you.